Hello everyone. In this video we're going to be solving a Quartic equation. We have x to the fourth power minus 24x equals 15, and we're going to be solving for x values. I'll be presenting two methods, and one of the methods will be incomplete. Let's start with the first method. For my first method, I'm going to go ahead and write everything on the same side and set my equation equal to 0. Now we have a Quartic that we can try to factor into two quadratics. One thing that is helpful here is we don't have x cubed, we don't have x squared. Especially we don't have x cubed would be a very helpful thing, because how do we get x cubed? By multiplying two quadratics, right? It comes from x squared times x. That means if one of the factors is something like x squared plus ax plus b, the other quadratic can be written with x squared minus ax, so that when you distribute x cubed, the coefficient of x cubed will be 0. Makes sense? And then we have to finish with another constant, because those constants don't have to be the same, right? Actually, they're not the same, probably, because their product is going to give us the constant term, which happens to be negative 15 in this case. And we're looking for rational values, right? It's kind of hard to find the irrational values. And this is going to give us a system of equations, which is going to eventually turn into a cubic equation at the end. But one thing that might be helpful if you're looking for integer solutions particularly, or rational solutions, is the fact that BC equals negative 15. So you could explore stuff like, maybe this is 5 and this is negative 3, this is 15 and negative 1, so on and so forth. So look at all the possibilities. Maybe this will make it a little easier. But guess what? This method is going to take a while. So if you go ahead and distribute, for example, you're going to get x to the fourth power from here. And then, as you know, x cubed is going to cancel out. So you're going to continue with cx squared. And then you're done with this, right? And then you're going to distribute to ax, which again is going to cancel out, minus a squared x squared plus acx. And finally, bx squared minus abx plus bc. If we know bc is equal to negative 15, we actually do know that, right? So you can write negative 15 if you want, but that's the only constant term, so no big deal. But what's really important is that putting together the coefficient of x squared. This is the coefficient of x squared, and this is the coefficient of x. And guess what that gives you? That gives you two equations, along with bc equals negative 5, which we already talked about, right? So the coefficient of x squared in the original equation is 0, and the coefficient of x is negative 24. And from the first equation, c plus b equals a squared, you can get something meaningful if you go ahead and factor out a here. That'll give you c minus b. And then eventually dividing both sides by a will give you c minus b, which is negative 24 over a. Along with c plus b, you can actually come up with another system. So here, you can find c and b in terms of a, right, by solving this system. And that's where you get the cubic. But when you multiply the cubics, it'll be hexic, but don't worry about it, because I think that'll be a bicubic or something like that. Yeah, should be easy to solve somehow. But anyways, from here, you should be able to solve, because you only have 3 unknowns and 3 equations. Make sense? And of course, the next thing you're going to use is BC, and we know that BC is negative 15. Once you solve for B and C in terms of A, you can go ahead and plug those in here. That's going to give you a single equation in one variable, which is A. Then you can just go about solving that equation. All right, great. That's pretty much the first method. It'll be incomplete, but I gave you all the ideas, so hopefully you can take it from here. Great. Let's go ahead and take a look at the second method. So with the second method, this was our original equation. I'm going to go ahead and add 24x, because I want to leave x to the fourth alone. And there's a good reason behind that. Let me show you. So we're going to be adding something to both sides. This is a really cool method. I forgot what the name was, but you probably seen it in my comments that were made by Nadia Fan. There were a lot of mentions of this formula, this method. It's a really cool method, so I'm grateful for that. And the idea is to make x to the fourth, to turn it into a perfect square. But obviously you can do it in so many ways, but we're going to do it in such a way that we add a quadratic term and a constant term. Does that make sense? Think about it for a minute, and then I'm going to show you what the solution is going to look like, okay? So here's how you can do it. We're going to be adding 2kx squared plus k squared. And you'll see in a little bit why this is helpful. And of course, you have to do the same thing on the right-hand side. And then we're going to have something interesting. First of all, on the left-hand side, you're going to get a perfect square, which is nice, right? On the right-hand side, let's arrange these terms a little bit, kind of putting the constants together. Notice that this is the coefficient of x squared, which is a. This is the coefficient of x, and this is our constant term, which is c. A, b, c, and in general, remember, we write a quadratic as ax squared plus bx plus c. Why is that important? Because I'm about to talk about delta. You know what delta is? Delta is the discriminant. So the left-hand side is a perfect square, so the right-hand side also needs to be a perfect square, right? And that's just perfect. So this means that the discriminant of the quadratic needs to be 0, okay? And what is the discriminant, or delta? B squared minus 4ac. And we want it to be 0 because perfect square means delta is 0, okay? Awesome. What do you do next? You probably divide everything by 8, right? If you do, and you can kind of isolate this, but let's go ahead and write this as follows. I'll probably write this part first. So 8k k squared plus 15 equals 576. Okay, so now if you go ahead and divide both sides by 8, let's think about it. If you divide by 4, you're going to get 144. By 8, it's going to give you 72. And 72 times 8 is 576, actually. Divide by 8, you're going to get 72. And this will be k cubed plus 15k equals 72. That's a cubic equation. How do you solve it? Well, you can solve it using the cubic formula or try to guess, because if you expect good solutions, k should be an integer, right? And in this case, k equals 2, for example, right? 8 plus 30, too small. K equals 3. 27 plus 45, just right. Great, awesome. So k equals 3 works. Obviously, for these kinds of problems that are kind of competition level problems, or some people call these problem contrived, usually the answer is nice. So k equals 3 gives us the following. All right, ready? X squared plus 3 squared equals 6x squared plus 24x plus 24. And you might be asking, how can the right-hand side be a perfect square? It doesn't even have a perfect square. That's okay. It'll be a semi-perfect square maybe, right? But here's the thing. You can factor out a 6, and that'll give you a perfectly perfect square, okay? It is just x plus 2 quantity squared. And this is good enough. We don't have to get rational solutions from here. And now you can go ahead and split it up into 2 pieces, considering the square roots. So one solution would be coming from here, square root of 6 times x plus 2. The other solution is going to be coming from the opposite of the right-hand side, and we're all set. And of course, we can continue to solve this problem. It's going to give us this, and then plus 3 minus 2 root 6 equals. So let me solve one of them. The other is very similar. From here, if you try to solve using the quadratic formula, negative b plus minus the square root of b squared minus 4ac. So a is 1. We can kind of write it like this, divided by 2. Let's simplify this a little bit. Square root of 6. And then this will give you 6 minus 12, but then we're going to get an 8 root 6 under the radical minus 6. And then of course this can be simplified a bit, but that's okay. We can leave it like this. Okay, it's a quartic, so it should have 4 solutions, and I think all solutions are real. Correct me if I'm wrong. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.